Your top line needs to be your capture or tensioning point for your track lines. So what we've done is established a high anchor point and then constructed a double 2-to-1 system. If you'll notice, all of our progress capture devices or prusiks on this system have been upgraded in diameter. We're accommodating for slippage and forces generated on that track line, and this needs to be the strongest element of the system. This system is built as two separate or independent 2-to-1s with a common travel point in the middle and one progress capture system of tandem prusiks for the entire 2-to-1s. The second tier down needs to be the belay system. Again, you're going to utilize a tandem prusik belay with the ability to integrate a haul system when needed. And your third system down is going to be a capture point for your lower haul system. That's it for the support side of the bank. Okay, as I mentioned before, there's a variety of ways to erect the system and to ferry lines back and forth across the gorge, the ravine, or the void. The fastest way is to pre-assemble all the tails, do the support functions like we discussed, and then deploy a messenger line from the support side. That line can be deployed by hand or it can be deployed by line gun, depending on the gap or the distance that you have to cover. Once the operational side receives the end of the messenger line, they're going to connect that messenger line to all of their system lines. Then I would radio over to the support side and communicate which lines are which. Because I'm using two white lines within my system and I don't have complete color variances, I've utilized two different types of carabiners to dictate my operational lines as opposed to my track lines. Once the system is clipped in, then the support side can haul the entire system over to their side. On the support side now, we've received all of our operational lines. We're going to separate the two systems between track lines and operational lines. The two track lines need to be rigged into the double 2-to-1s and then tensioned. If you have a dynamometer, this is the ideal place to put it, between the anchor system and the hub of your double track lines. That will help you evaluate how much force you're actually applying to the system prior to operational loading and during operational loading, and you can make appropriate adjustments as needed in the tensioning of the system. As you can see, we've integrated or rigged our dual track lines into our double 2-to-1 system. As I mentioned before, we've upgraded the diameter of the prusiks that we're utilizing. 8 mils would give us about 1,000 pounds. At 1,000 pounds, they'd begin to slip. With 9 mils, we're going to be able to get to about 1,500 pounds before they slip. So for every mil of diameter on your prusik, you can add roughly 500 pounds of resistance to the slip factor. I'm now ready to rig in my operational lines. You have a couple of options on your belay line. You can use two separate belay lines, one on each side, or you can use a common one that has stop points or rig points onto the movable control point itself and plays through. If you use a common belay line, you need to make sure that it's long enough to accommodate whatever function it is that you're utilizing it for. So it needs to be able to traverse or travel completely from one bank all the way to the other bank. In our case this morning, we're going to go ahead and use one common belay line. The red we've designated as our belay line, so I'm going to go ahead and take this line and I'll start rigging it into my system as a tandem prusik belay. For the lower haul line, is all that's required is that you clip it into an anchor point. The support side is now completely operational.